Hey everyone, welcome back to DevOps Talk. If you have just joined in, this is part 2 of the Ultimate Docker Workshop. And in this session, we are going to understand why Docker even exists and how it completely changed the way we build and deploy applications. So before we start running commands and building containers, it's super important to understand the why behind Docker, why it was created, what problems it solved, and how it revolutionized modern software development. Because once you get this part right, everything else from building images to deploying containers will make a perfect sense. Right? So here's what we'll cover in this session. Introduction to Docker, why containers changed everything. The second one is the problem before Docker. Third one will be what is a container, what is Docker, how Docker works, the evolution from VMs to containers, why Docker is needed. If Docker didn't exist, then what would happen? Docker in today's ecosystem. Then at last we'll do a small recap. Alright, then let's go through introduction to the Docker, why containers changed everything. Before we start hands-on, let's understand why Docker exists, what problem it solves, and how it transformed modern development. So the problem before was challenges was like developers and operations face the classic work on my machine problem. Applications behave differently in dev, test, and production environment. So dependencies, versions, and configuration were hard to manage. Virtual machines were heavy, slow to start, and resource consuming. So I'll explain it a little bit. Let's say you built a Python application on your laptop. It runs perfectly. You have you have got all the libraries and tools installed in your local machine or in your laptop, so everything works fine. But when you deploy that same app to a production server, it fails. Why why because the server doesn't have the same setup. Maybe a library is missing or a version is different. This is the classic work on my machine problem. So before Docker, developers and operation teams spent hours of fixing these environment mismatches. Because your dev and production team, they might have different environment setups. So Docker solves this by packaging your app with all its dependencies inside a container. So it runs the same everywhere on your laptop, test, or production environment. So this is the problem which we were facing before Docker comes in. Then we'll see what is a container. So the definition is a container packages your application along with its dependencies and configuration. It runs isolated from other apps but shares the same OS kernel. So it is lightweight, fast, portable, and consistent across environment. Why it is lightweight? Because it uses the same kernel. It's not a VM. And it is fast because we are reusing the OS kernel. But in VM, there would be different kernels for different VMs. So that's why it is lightweight, fast, and portable and consistent, because in the container we have all the dependencies inside it, right? So I'll give a small analogy. Let's say in the real world, shipping containers changed the global trade. So before that, goods were packed in different shapes and sizes, moving them between ships, trucks, and trains, and that was messy and slow, right? So then came the standardized containers, same size, same format, and suddenly you could transport anything else anywhere using the same system. Similarly, in software, every app used to have its own setup, dependencies, and configurations, making deployment messy and unreliable. Docker containers standardize this process. In a one-liner, think of containers like shipping containers. No matter what's inside, they can be transported anywhere using the same system. And what is Docker? So Docker is a platform for building, running, and managing containers easily. Automates the process of creating containers from application code and provides tools like Dockerfile, image, container, and Docker engine. Dockerfile is a blueprint of how to build an image, whereas image is a snapshot of your application and its environment. And container a running instance of that image, and Docker engine the runtime that executes the container. So in simple words, Docker in Docker file you will give the blueprint for the image. Using the Docker file we will create the image, and to run a container, to run an instance, we need the image. So from the image we will run the container, and the Docker engine executes the containers. For example, you build an image once and it can run anywhere, laptop, server or cloud. Then how Docker works? So I have simplified it a bit. You write a Docker file describing your app setup. Docker builds an image from the Docker file, and you can run the container, an isolated environment running your app. Multiple containers can run on one system, all sharing the host OS kernel. So here is the key takeaway. Docker isolates apps without the overhead of full virtual machine. And this is the evolution from VMs to containers. Each VM had a full OS, slow to boot, large in size, high memory usage. If you ever use any virtual machine, you might aware of this, because every VM has their different setups, different OS and different kernels. It's very slow to boot every VMs, and they are large in size and they use high memory usage because they have their own OS. Then the containers with Docker, it shares the same OS kernel and start in second because it is lightweight, consume less space and are easier to scale. So the analogy will be, think of like virtual machine as a house. Each house has its own foundation, walls, plumbing, so everything is separate. That's like VMs. Each one runs a full operating system taking up more space and resources. Now think of the container as an apartment in the same building. They share the same foundation, the host OS, but each apartment is still isolated and independent. So with containers you get isolation like a VM, but they are lighter, start faster and use fewer resources. No matter what's inside, Java, Python, Node or Golang, Docker can run it anywhere. Your laptop, it could be a test server or it could be a cloud. So why Docker is needed? Why? Because it eliminates the works on my machine problem, provides consistency across dev, test and prod, simplifies deployment and scaling, ideal for microservices and cloud native architectures, integrates seamlessly with CI/CD pipelines. So for example, Docker makes sure your app behaves the same no matter where it runs. So if Docker didn't exist, every app would still need its own VM or manual setup. Then scaling apps would be very slow and costly. Environment mismatches would cause frequent production issues. Automation and DevOps culture wouldn't have evolved this fast. Cloud native and microservices adoption would be very limited. Docker didn't just solve the problem, it changed how we build, test and deploy software. So Docker in today's ecosystem. Docker is now a part of foundation for developer, CI/CD pipelines, microservices and Kubernetes and cloud. Docker is the building block of modern DevOps and cloud native architecture. So here is the small recap. Before Docker, things were complex, inconsistent deployments. Docker introduced lightweight, portable containers. Then what Docker solved? Environment drift, scaling changes and speed issues. And today, core technology behind Kubernetes, DevOps and modern apps, which is Docker. Alright, so now that you understand why Docker exists, so we'll jump into how to use and start containerizing our first application. And that wraps up our Docker introduction. We started by understanding why Docker exists, the problem it solved, and how it completely transformed the way we build, package, and deploy application. In the next part of this workshop, we'll start getting hands-on, installing Docker, running our first container, and exploring the real commands that make all this magic happen. If you found this session helpful, make sure to hit the like button, subscribe if you haven't already, and check out the full Ultimate Docker Workshop playlist on my channel. This is just the beginning. There's a lot more practical stuff coming up. Thanks for watching, and I'll see you in the next part.